so we're going to go over problem number 2 here. Why? Because I don't feel like going over problem number 1. And we need to do, first we need to do the why and then the how of this. So, in our why, we need to explain why the universe works this way. First, I would note that a position time graph gives the location of the object. So, I'm going to go up here to my sheet. Why we're doing number 2. A position time graph shows location. So it's just, I mean, that's really basic, right? Position time graph shows location. But it's a good place to start. Easy. Position time graph. And then, if you look, the questions are all about the velocity of the car. I will be one second. What's velocity related to? What is velocity? The rate the position changes. So that would be the next fact I would put up there. It is something along the lines of like velocity is the rate the position changes. So velocity is the rate the position changes. It's showing you understand the relationship between velocity and position. Now, how is the rate of change shown on a graph? What feature of a graph shows rate of change? Slope. So that brings up our next fact. If velocity is the rate of change of position, then the velocity is the slope of the position time graph. So that would be my final fact I would be looking for up here. Velocity is the slope of the position time graph. Now, you're welcome to put it in your own words. However it makes most sense to you. I'm pretty good at interpreting. Notice I use a lot of abbreviations. That's because I'm lazy writing on the board. But those are the 3 main ideas I'd be looking for when I read your why on this problem. Did they get these 3 main ideas in there? Did they show understanding of them? I'll tell you the 2 important ones. The really important one is that the velocity is the slope of the position time graph. And then secondary important is velocity is the rate the position changes. The first one, I wouldn't take off if you didn't have it. And I would understand that you understand a position graph. All right? But those other 2, very important to have in there. Any questions on that why? All right. Now, I'm going to grab the graph. I have it. And let's see, what do they want to know? Find the velocity of the toy car with the following time intervals. Indicate the direction with the sign of your answer. All right, so let's do this. So we have for A, we have from time 0 from here to 2 seconds, so to here. Now, how do I find slope? Rise over run. So my slope is rise over run. And we said the slope is the velocity, right? That would be V. Actually, we put a hat on it because it's velocity. My rise, that's the y-axis here. What's my y-axis measuring? Nope, that's the x-axis. Which would be a measure of what unit, that position, right? Well, that was the first thing I wrote in my y, wasn't it? So the y-axis is measuring position, and so the rise is actually the change in position. And then the x-axis is measuring time, and it's actually the change in time. That's from our equation sheet, isn't it? That's the definition of velocity, and that's why it's that. So I want to figure out the velocity for the first 2 seconds. So I'm going to say velocity equals my rise, which is my change in d, and I know change is final minus initial. So my final position is 3 meters minus my initial position 0 meters over my time, which is 2 seconds minus 0 seconds, which equals positive 1.150 meters per second. That's right? Yeah. That would be a plus, because it's positive. And it asks me, indicates the direction of the sign of your answer. So they're actually asking me for velocity, but since the answer came out positive, I implicitly put the positive sign. Moving on to B. Yep, right here on our equation sheet, notice that delta stands for final minus initial. So whenever you have a delta in front of it, you always have the final minus the initial. Nope. Let's do this one and we'll see. So the next time interval they ask us for is from 2 seconds to 4 seconds, right? So we're doing the same thing. V equals, now my final position to me looks like 0.5, negative 0.5. So negative 0.5 meters. My starting position was 3 meters. My ending time is 4 seconds. My beginning time is 2 seconds. Everyone agreed? Did I get the right numbers? What's your graph? I think I did. Yes? Well, I looked at the graph, and the first position would be where it is at 4 seconds. So I went out the x-axis till I got to the number 4, and then I went down to the red line, which is the trace on the graph, and at that 4, it is at negative 0.5 position. And so that was my first, and then I went back to where was it at 2, and at 2, it was at 3 meters. All right? So I'm pulling them from the graph. So I'm subtracting where its final position minus its initial position. So I end up with negative 3.5 meters up top and 2 seconds down the bottom. Gives me negative 1.75 meters per second. I hope it's correct, and it is. You guys did C with your table group. What'd you end up with? Okay, so put that into a number with meters per second. Excellent, 0 meters per second. And that's what it is, because V equals, I end up at negative 0.5 meters. What? 0 is the one number in the world that does not have a positive or negative. So it's non-directional. Plus 0.5 meters over 6 seconds minus 4 seconds. Why does it end up being positive? 2 negatives. Excellent. And that ends up being 0.00 meters per second. Rule of thumb, Always give me 3 sig figs, please. In your answer. Keep all your sig figs if you're working, and then just post 3. And what about D? Why is what? It is, but anything 0 over anything. I skipped that one math step, sorry. Huh? You told me 2 negatives. Negative 0.5 minus negative 0.5. And then part D, let's see, I end up at 0. I start at negative 0.5, and I go for 3 seconds. So B, I end up at 0 meters. I start at minus negative 0.5 meters over 9 seconds minus 6 seconds. And that equals 0.167. 0.167 meters per second. Positive. Yes, it is. Yes, I figure you're getting better at those, so I would need to write them less.